EdgeClaw destroys OpenClaw. Every time you use an AI agent, your private data goes somewhere. Passwords, your SSH keys, your API keys, personal files, all of it, and straight to the cloud. Most people have no idea. You think you're being productive, but you're also handing over sensitive data to a cloud server you don't control. There's now a tool built to fix that, and it's free, and it's open source. Stay with me, because this one actually matters. Hey, I'm the digital avatar of Julian Goldie. Help people learn how to actually use AI tools in their work. Just talk about them. Actually use them. Today we're breaking down EdgeClaw, what it is, why it exists, how it compares to OpenClaw, and whether you should actually use it. Let's get into it. First, let's talk about OpenClaw, because you need to understand what it is before we talk about what EdgeClaw does differently. OpenClaw is an open source AI agent that runs on your machine, connects to AI models like Claude or GPT, and then it does things, real things. It can execute shell commands, read and write files, browse the web, send emails, manage calendars, and automate tasks across your digital life. You interact with it through messaging apps like Slack, Telegram, or WhatsApp. It's one of the fastest growing repositories in GitHub's history, with 135,000 stars, a massive community, and it's genuinely powerful. Here's the problem nobody talks about enough. When you use OpenClaw, everything goes to the cloud. Every request, every message, every file it touches, all of it sent to a cloud model. That includes your database connection strings, API keys, payslips, SSH keys, passwords. If you work with private information, that's a serious problem. And it became an even bigger one earlier this year when a critical vulnerability was found in OpenClaw, CVE 2026-25253, a one-click remote code execution bug. Security researchers found over 21,000 exposed instances publicly accessible on the internet, leaking API keys, OAuth tokens, and plain text credentials. OpenClaw patched it, but the attack surface is real. And the core architectural issue, all data going to the cloud, that's not a bug. That's how it was designed. That's the gap EdgeClaw was built to close. EdgeClaw launched in February 2026. It's open source, MIT licensed, and built by a serious team. Tsinghua University's Natural Language Processing Lab, Renmin University of China, Model Best, and OpenBMB. This is a research-backed project with real academic and industry weight behind it. The core idea, EdgeClaw adds a layer of intelligence between you and the cloud. Instead of sending everything to the cloud, EdgeClaw runs a detection system locally on your machine. It looks at every single request before it goes anywhere, then makes a decision. Is this safe to send to the cloud? Does it need to be cleaned up first? Should it stay local entirely? They call this three-tier security collaboration. For one is S1, if data. Requests like, write me a poem about spring, nothing sensitive, straight to the cloud. For two is S2, sensitive data. Numbers, email addresses, home addresses. EdgeClaw detects the private information, replaces it with a placeholder, something like redacted phone, sends the sanitized version to the cloud, gets the response back, and fills in the real information only on your local machine. The cloud model never sees the original data. Level 3 is S3, private data. SSH keys, passwords, payslips, private certificates. This never leaves your device. EdgeClaw runs a local AI model, Mini CPM 4.1 through Ollama, to handle everything entirely on your machine. The cloud only gets a locked placeholder. For more, let me talk about how the detection actually works, because this part is clever. EdgeClaw uses two engines running together. The first is a rule-based detector, essentially 0 milliseconds. It uses keyword matching and regex to catch known patterns instantly. API key formats, database connection strings, SSH private key headers. Fast and reliable for anything predictable. The second is a local LLM detector. This runs a small local model to understand the semantic meaning of a request. It takes about 1 to 2 seconds, but it catches what patterns can't. For example, if you write analyze this payslip for me, a pattern detector won't flag that. A local language model understands the context and classifies it as private data. Both engines run before anything reaches the cloud. And here's what makes the memory system interesting too. EdgeClaw maintains 2 separate memory files, one that the cloud model sees, always auto-sanitized, and that the local model sees complete information. The cloud never touches the full memory file. That's enforced at the file access layer, not just at the prompt level. Let me show you why this matters for your actual workflow. Imagine you're a developer refactoring code that has database connection strings and API keys in it. Standard OpenClaw, those strings go to the cloud. With EdgeClaw, the rule detector catches them in 0 milliseconds, routes that task to your local guard agent, and the cloud model only sees the broader project structure. Your credentials never leave your machine. Imagine you're doing a lot of routine work, while browsing, reading code, answering simple questions. Every one of those requests going to your most expensive model is unnecessary. This is where EdgeClaw's second major feature comes in, cost-aware collaboration. EdgeClaw uses a local small model as a judge to assess the complexity of every request. Simple tasks like translations, formatting, basic questions get routed to cheaper, faster models. Complex tasks like multi-file refactoring or system design go to more powerful models. Reasoning-heavy tasks like mathematical proofs or formal logic get routed to models built specifically for that. According to the EdgeClaw documentation, in a typical coding workflow, 60 to 80% of requests can be routed to lower-cost models. That adds up fast. Around the time I was really getting into EdgeClaw, I realized how much there is to figure out with AI tools. Which workflows save time, which ones waste it, which setups are actually worth it. That's exactly why I created a community called AI Profit Boardroom. Over 2,000 members all focused on learning AI together and sharing what actually works. The community shares real use cases and practical implementations. If you're serious about using AI to improve your work and skills, check it out. Link in description. Now let's talk about setup, because this is where EdgeClaw gets practical. You don't have to rewrite your code or workflow to use it. EdgeClaw runs as a plugin called guardClaw inside the OpenClaw environment. Intercepts requests through a system of 10 hooks that cover the entire lifecycle of an agent request. You add it to your config file, point it at your local Ollama instance, and it works. No changes to your business logic. New code to write. In late March 2026, they also released Clawx Router, a more advanced routing system with 5-tier cost-saving routing, the 3-tier privacy collaboration, and a visual dashboard so you can actually see what's being routed where in real time. And if you want zero configuration, ModelBest, one of the development partners, has launched EdgeClaw Box, dedicated hardware that comes with EdgeClaw pre-installed and ready to go. Who is EdgeClaw actually for? If you're a casual user who only uses AI for general tasks, drafting posts, generating ideas, answering questions, the privacy layer probably doesn't matter much for you. Standard OpenClaw is fine. If you're a developer or someone who works with client data or anyone whose agent touches files, credentials, or personal information, EdgeClaw solves a real problem that most AI agent tools currently ignore. It's not a one-click install. You'll need to install Ollama, pull the mini CPM 4.1 model, and work through the config. But it's all documented in the repo at openbnb/EdgeClaw on GitHub. If privacy in your AI workflow matters to you, it's worth the time. And there's more to cover here that I'll get into in upcoming videos. The Clawx Router dashboard in depth, the dual-track memory system, how the Guard agent handles S3 requests end-to-end. Stick around for that. If you're looking to dive deeper into AI tools and actually implement them in your work, I recommend AI Profit Boardroom. Over 2,000 people learning how to use AI effectively. Everyone shares real experiences. What's working? What's not? Which tools are worth your time? Which ones to skip? Hype. Just solid, practical guidance from people doing the work. It's helped me stay on top of updates and figure out how to actually apply them. Link in description if you want to check it out. And if you want the full process, SOPs, and 100 plus AI use cases like this one, join the AI Success Lab. Links in the comments and description. You'll get all the video notes from there, plus access to our community of 58,000 members who are crushing it with AI. See you in the next one.